crosses two other lines. We kind of set up four groups of angles where they cross, right? And it develops a bunch of vocabulary words that we had gone over. So, in the first example, 3-1, what would angles 2 and 8 represent? Alternate exterior, perfect. What would 1 and 3 represent? Vertical angles. So even though these aren't parallel, our vertical angles are what? Still congruent no matter what. Vertical angles are always congruent. What would we say about 4 and 5? Consecutive interior, okay. What would we say about 5 and 6? What? A linear pair, perfect. What would we say about 4 and 6? Alternate interior, right? And then what about 1 and 5? Corresponding. What is corresponding mean again? They're in the exact same spot with respect to those groups of 4, right? Okay? So then we carry on to the next section, and basically you do the exact same thing. But now because my lines are parallel, what's special about alternate interior, alternate exterior, and corresponding? They're what to each other? Congruent, right? And then what's special about consecutive interior? They are supplementary or equal 180. They are not a linear pair. They're supplementary. Okay, so the biggest thing some of you still have a hard time with is reading the directions, because in this particular case it says in the figure, measure of angle 1 is 123 degrees. Find the measure of each angle and tell which postulates or theorems you used. So, based on those directions, how do I find angle 5? What relationship do 1 and 5 have? Alternate exterior, and if angle 1 is 123, then 5 is? Perfect. So, what is angle? Now keep in mind that we just figured that out. What are angles 11 and 5? Right? Because? Perfect. Alternate interior because of, 123 because of alternate interior. What would we say about 12 and 5? Consecutive, exactly right. So if 5 is 123, what's 12? Come on. Thank you. Because, again, as Kenzie said, they are supplementary, right? What about 5 and 3? (123) because vertical angles. Perfect. What about 5 and 7? Corresponding. So again, it is 123.
So what postulate?
I would just say corresponding angles. Okay? Because you probably aren't going to remember them. You know what I'm saying? Everybody good with that? Okay, so again, how do I know that the lines are parallel? The little arrows, right? The play buttons or the fast forward buttons. Okay? But again, as in 3-1, we still have all those things, they just don't have the special characteristics of being congruent or equal to 180. Good with that? How do I find the slope from any 2 points? What's my formula? Good. Say it louder.
y2 minus y1 over x2 minus x1.
Thank you. The difference of the y's over the difference of the x's? If they are parallel lines, what's true about my slopes? They're the exact same. If they're perpendicular, opposite reciprocals. We definitely want to say opposite, right? Because we're changing the sign. Don't just say negative. So, 21 through 23, any of those you want to see? Or graph the line that satisfies each condition. 24 or 25? Yes? Which one? Let's do 24. So in number 24, read the directions or read the problem. So in number 24, what am I going to do? Graph it. Okay, what am I going to graph first? Okay, so where do I go for 2, 5? Over 2, up 5. Okay. And that goes with what point? Yeah, okay. But what's the other point that goes with it? 9, 2. So 9, 2. So I'm going to plot those two, and then I'm going to connect them. And what do I have to figure out from that right there? I have to figure out the slope. So I want to know what this slope is of that line. So again, I go and look at it. It doesn't really look like it. The only place that it crosses are those 2 points. So now I'm going to figure out my slope. So from here to there or from there to there. It doesn't matter. It's going to end up being the same numbers, right? I'm going to start from here. So I'm going to go down 1, 2, 3. If I go down 3, it's -3. And then, so basically right there is where I'm at right now. Now I'm going to go across. So from here to here, 1, 2, 3, 4, 5, 6, 7. So my slope is -3, 7. Now, what did the problem say? Find a line that is parallel or perpendicular? Parallel. So if it says parallel, I'm going to use that slope again. Now, what's the other point that they gave me? -3, +4. Okay, so there's my point, and now what do I do with this point and this slope? I just apply my slope to that point. So where do I go? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. And I should really do it again. And then last but not least, I would connect my dots. And put little arrows on it because I want it to be a line. And so this line is parallel to the original line that had those 2 points through that third random point. Now, if it said that it was perpendicular, then I would do the same exact thing, but I would come back and do my opposite reciprocal to this. So I would have flipped it and made it 7/3, and then from this, I would have went up 7 to the right 3, and then I would have got my perpendicular 7. That's basically a lot what you should have done for today's assignment also. Okay. That makes sense to everybody? Okay. So 24 was that, 25 was the perpendicular one. So you would have to do the same process, but then find your perpendiculars. So we're good with that? Section 3.4, equations of lines. What are my formulas for the equations of a line? What is my slope-intercept form? Y equals mx plus b. So again, this is something that you need to make sure that you understand the vocabulary. Y equals mx plus b. Okay? And this was called what? This is slope-intercept. And then what was point slope? Awesome. Now, what's the difference between y and y sub 1 or x and x sub 1? What is the difference between these right here? Which one's the point? Right, the ones that have the subscript are the actual points. The y and the x that don't have the subscript are actually y's and x's. They're variables. Okay? So, in number 27 and 28, it says write an equation in point slope form of a line having a given slope that contains a given point. So again, those shouldn't be very easy or very hard because all you're doing is taking that information and sticking it into the formula. Now, if it, in 27 and 28, if it said to graph those, then it could be a little bit more because I would have to simplify that equation that I set up and use it on my coordinate plane. Okay? So, 27 through 32, any of those you want to see? Again, we got time, so if you want to see it, make sure you yell something out. What number? 28. So 28 says, write an equation in point slope with a slope of -3/4 and h -1. So we're going through this point and using the slope of -3/4. Everybody agree? So, what am I going to do? They tell me to put it into this equation right there, right? So, what do I write? Y minus -1 or plus 1, right? Because this is minus -1 equals -3/4 times x minus 8. So again, if they just told us to do this in 28, I'm done. If they told us to graph this, then I have to simplify this. So let's carry on and do that. If they told us to graph this, if I'm going to graph this, this just goes back to algebra. I'm going to distribute my slope through my parentheses. So I get -3/4 x, and if I take -3/4 times -8, what do I get? Well, two negatives make a positive. My 4 cancels this 8 to a 2, so I get 6. Everybody good with that? Now, how do I get y all by itself? What do I subtract 1 from? Just the 6, right? -3/4 x and 1 cannot be subtracted from each other because they're two different things. So 6 minus 1 is +5, and then I'm ready to use that if I have to graph it, right? So if I have to graph this, where am I going to start? +5, right? This is my y-intercept. It always tells me to go up or down, and it's positive, so Kenzie said up 5. And then where does my slope go? Down 3, and which way for? To the right. So one negative does not make both of them negative. It's just either the top or the bottom. But you can put it either way, and you're still going to get the exact same answer. So do you need to see that actually graphed? Okay. So if you continue looking at where we're at, the ones 31 and 32, the first step in 31 and 32 is what? I actually have to find my slope. So that's where I'm going to use what Cora told us. This equation right here, right? And the only thing that matters is whatever y I use, I have to use that same x in that order. Okay, so then I would use that slope in one of those points and do the same thing that we just got done doing. So do we need to do one of those? Yes, no. No. Okay. All right, turn the page. So, 34 through 37, basically the same thing that we just talked about in sections 3.1 and 3.2. But now, all of our rules or our postulates would actually have to say what word with it? The converse, right? So now we don't have parallel lines in our figure, right? We're trying to prove that those lines are parallel. So the information that is given to us, we would maybe set it equal to each other, or we would set it equal to 180 degrees and see if it works out. And then if it works out, we can still use those vocabulary words, but we would say the corresponding angle's converse. or the converse of alternate exterior angles, or whatever it happens to be. Make sense? So in number 34, do angle 7 and angle 10 equal 180 degrees? Looks like it, right? And so we would say what? The converse of consecutive interior. If angle 10 and angle 2 are congruent, do I know anything about that? Do angle 2 and angle 10 have a direct relationship? Angle 2 and angle 10 don't have anything to do with each other. So we don't know if they try to tell us that they're congruent, no big deal. But we have no way of proving that in that figure right there. Because remember, my transversal has to touch both of those lines. And neither of the transversals, W or X, would touch 2 and 10. If angle 1 and angle 3 are congruent, what would we say about them? Corresponding. What is my transversal for that problem? V. Exactly right. If angle 3 is congruent to 11, do they have a relationship? Alternate exterior, and what's my transversal again? X. Perfect. And then, of course, the great review doesn't even show you one of those that you would want to see. So, let's go over to 20 or 21. And look at maybe both of these. 20 and 21 would be what we did for today. Anything else that you want to see from previous sections before we do these problems right here? So actually, you guys did very well with all the alternate interior and exterior things. So keep up. Remember now, if you're going to use a graph, which I would definitely use a graph for these problems right here, as some of the ladies came in this morning, they found out that the graph is beneficial, or just don't think so much. I know some of you are actually thinking, which is great, but some of you are overcomplicating the problems. Okay, so let's look at number 20. How am I going to do number 20? Read the directions. Find the distance from P to L. L, though, is a line. All right? So the first thing that I have to do is what? Draw my line, right? Or plot my points for my line. So where do I go to plot my points for my line? Say it louder. -4. -4, 2. And my other point? So again, I'm going to plot those 2 points, and then I'm going to connect my dots. From there, I am going to plot my other point, the third point that they gave me. And that point is where? 1 what? 1, 2. Over 1, up 2. So, again now, I'm going to try to find the distance from this point to that line. So, the first thing that I have to do is figure out what is the slope of this line right here. So, m is equal to what? Well, again, I'm going to find something that's really close together. So, these two look really close together. And if I go down 1 over 1, that's my slope. But now, I want the perpendicular slope of that. So you always find the slope of your original line and then the perpendicular slope, because the perpendicular means that I'm drawing a straight line from my line back to that point, and the straight line is the fastest way of getting somewhere, right? So what's my perpendicular slope? Obviously just positive one, right? So then from my dot, what? This point's wrong? Because it's what? So we're going to go up 1 over 1, up 1 over 1, and now I'm going to connect these dots, but they have to hit my other line. So now, if I look at this, here's definitely my dot, and here's my dot of this one. Can I realistically tell everybody in the world what that dot is? No. So if I cannot figure out what that dot is, I have to have a way of finding that. And that's where it's mathematically found by doing the systems of equations. Now again, I'm pretty sure when you do this on your quiz tomorrow, it's a nice one. Meaning this point would hit like right there. And so then we could draw our right triangle and figure it out. But let's do the math. So if you're going to do the math for this, what is the equation of this line right here? Can we figure it out? Well, it looks like this is my y-intercept. So what's my y-intercept? -2. And what's the slope of this line right here? -1. So we would have -1x minus 2. What is the equation for this line right here? So here's my y-intercept. So we would have said y equals +1, right? And what's the slope of this line? 1x. So I'm going to take those two equations and either do substitution to it or elimination. Which one do you want to do? This one's going to be easy either way. Elimination looks really good. Y equals 1x plus 1, 2y equals -1, y equals -1x. Everybody agree? Just math. So now I take this and put it back into my equation. Where should we put it? Doesn't really matter. This one right over here. -1/2 equals 1x plus 1. How do I get x all by itself? Subtract 1. What's -1 and -1/2? -3/2 equals my x. So here's my point. So that point right there is this circle right here. So now I'm going to do the distance formula with this point, which we just found, and this point, which was given to us. What was this point again? 1, 2. So I would take both of these points and stick them into my distance formula. What are my x's? -3/2, minus or plus inside? -1 squared plus -1/2 minus 2 squared, and then I would just finish doing the math. Okay? Now, if this one would have came down here, let's just say this line was shifted and it would have hit right here where this line came. Everybody see where I'm at? If that's true, I myself am going to make this triangle right here. Why? Because then I can just count 1, 2, 3, and 1, 2, 3. And if I know the A and the B, I can come back and do Pythagorean theorem. So essentially, it's the exact same thing that I'm doing here. Look, something squared plus something squared equals my D. It's the exact same thing. It's just a little faster process. But again, I could have tried to do it here, but then I would have basically been guesstimating at where that point is. Now this one looked like it was pretty much right in the middle, which it was, but we're not going to know that unless we actually do the math. That's why if it hits that crosshairs, it's way easier to do. Okay? But again, I definitely recommend, now Cora did it, one of the problems all by doing the math. That's totally fine. But it was a lot of work, wasn't it? And there was a lot of part of the paper. So, yeah, there's still quite a bit of work here, but if this is right on my crosshairs, the work's not as bad as what Cora eventually had to go through. Okay? So, shall we try 21? Or do you want to try 21 overnight for practice? You want me to do it? Yeah. All right. So, in 21, the first thing that I'm going to do is graph. So what point or points make up my line? 6, 5. 6, 5. Why do I have 2 5s? That's weird. 6, 5. And what was the other one, bud? 2, 3. 2, 3. So I connect my dots. Can I tell my slope? Well, these aren't too far apart, but I could even make it closer by using this point right here, right? So what's my slope? 1/2. So what's the third point they gave me? 2, 6. 2, 6. And what's my perpendicular slope? -2, right? Because I'm flipping this and changing the sign. So from this point, I'm going to go down to 1, 2, and over 1. Down 2, and over 1. So again, this one wasn't nice to us either, because they still didn't cross us right. So we were trying to figure out what this stubborn point is, right? So again, what's the equation of this line? This first one right here. This line would be up to, and what was my slope? 1/2. And what is my perpendicular one? Well, this one we didn't extend far enough because we need our y-intercept. Looks like +10. So my other one would have been, and what was my slope? -2x. So again, do I want to do substitution or do I want to do elimination? That's totally up to you. We'll substitute this one. Perfect. 1/2 x plus 2 equals -2x plus 10. Let's add 2 to this. So 1/2 plus 2 is 2.5, or what, 5/2? And that means we're subtracting 2, so we get 8. So x is, if I multiply or divide by 5/2, I'm really multiplying by 2/5. So we got 16/5. So again, this one's a real stinker, right? Because it's 16/5. That's even worse than our other one. But then we would take this and stick it back into our equation. Again, it doesn't matter, but we already have fractions, we might as well use fractions. So y equals this times 16/5. So what do I get? Looks like 8/5 plus 2. So this would be 5/10. So this would be y equals 18/5. So there's my point. 16/5, 18/5. And my original point was 2, 6. So again, I would take those 2 points and stick them into my distance formula. Now, if I'm going to do distance formula with this problem right here, I'm using a calculator and turning this into decimals. Okay, so I'm punching 16/5 into my calculator to get a decimal. And then I'm going to use that in my calculation. Okay. But again, if you take the time to graph these, I know it doesn't help when it's like this either way, but it's still easier for me to look at it and figure out what my lines are to set up my system of equations than me trying to visualize it in my head and do the math before I graph it. But it still works because you got the right answer. Okay. So, again, tomorrow the quiz only goes back to the lines, or the slopes and the lines. So you only have to do slope, perpendicular and parallel slopes, writing equations of lines, and then one of these problems. So you will have to do one of these problems tomorrow. I think you have to do one of these tomorrow and then the next day on a test too. But as I said, I'm pretty sure they work out where it's perfect. Meaning that cross or that intersection point is right on one of those crosshairs, so it's a lot easier for you. Make sense? Questions?